You've probably heard the term XSS, or cross-site scripting, in cybersecurity. But what does it actually mean? And more importantly, what does it look like in real life? In this video, we're going to break down exactly what XSS is and how attackers use it to run malicious code in your browser, often without you even noticing. And don't worry, this won't be some abstract theory lesson. I'll walk you through a simple, real-world example using OWASP Juice Shop, a deliberately vulnerable app that makes it easy to see XSS in action. Let's jump in. Cross-site scripting, or XSS, is a type of vulnerability that allows attackers to inject malicious scripts into websites. What makes it dangerous is that the script doesn't run on the attacker's machine. It runs in your browser, as if it came from the website itself. In other words, the attacker tricks the website into including their code in a way that makes your browser trust it. And since the browser thinks that code is coming from a trusted source, it will execute it, no questions asked. That means attackers can do things like steal your session cookie, fake login forms, or even redirect you to phishing pages. And all of that happens without the website owner or the user realizing anything is wrong. To really understand how dangerous this is, let's take a look at a simple example inside OWASP Juice Shop, a deliberately vulnerable web app. I'm on a product page and I'm going to leave a review. Instead of plain text, I enter a small script tag, something a real attacker might try to sneak into a comment field. When I submit the review, the website displays it as plain text. That's good. It means the input is being escaped properly, so the script doesn't run. But what if the site wasn't built correctly? On a vulnerable website, this script would be saved to the database, just like any other review. Then, whenever someone loads the review page, their browser would run the attacker's code automatically. That could mean showing a fake login prompt, stealing a session cookie, or silently redirecting the user to a malicious site. And the worst part? The user would never even notice that something was wrong. This isn't just a theoretical risk. It's happened in real life. In 2005, a teenager named Sammy Camcar unleashed a stored XSS worm on MySpace. Anyone who visited his profile triggered JavaScript that added Sammy as a friend and copied the payload to their own profile without consent. The worm also displayed the phrase, "But most of all, Sammy is my hero," on infected profiles. In less than a day, over 1 million MySpace users were infected. That's what a single XSS vulnerability in a comment or profile can do in a real application. What we just saw was an example of stored XSS, where the malicious script is saved on the server and delivered to every user who views the page. But that's just one type of XSS. The second is reflected XSS. This happens when the malicious code is part of a URL, like a search query, and the website reflects that input right back into the page without filtering it. Reflected XSS doesn't persist. It only works if the victim clicks a specific link crafted by the attacker. And then there's DOMbased XSS, which is a bit different. In this case, the attack happens entirely in the browser, through JavaScript on the page that handles input in an insecure way. The malicious payload never touches the server, but it still gets executed in the user's browser. All three types rely on one thing. The browser ends up executing malicious code, not because the user did something wrong, but because the application didn't properly validate or sanitize input. In stored and reflected XSS, the server is involved in delivering the payload. In DOM-based XSS, the attack happens entirely in the browser, triggered by insecure client-side code. These aren't edge cases. Cross-site scripting has been on the OWASP top 10 list of web vulnerabilities for years, and it's still one of the most commonly exploited issues today. In all cases, the attacker supplies the code, but the real issue is how the application handles it. Whether it's server-side or in the browser, the result is the same. The browser runs code it shouldn't trust. So how do you prevent that? Always sanitize or escape dynamic content before inserting it into the page. That means converting special characters like less than and greater than signs, quotation marks, and apostrophes into harmless representations, like these. So instead of the browser treating them as part of a script or HTML element, it just shows them as plain text. That one step can turn a potential XSS attack into nothing more than a weird-looking comment. Escaping is the most basic and effective defense against XSS, especially for content that ends up in the HTML output. Another important layer of defense is input validation. That means checking whether the input even makes sense before you process it, like rejecting numbers in a name field or blocking script tags in a comment box. It won't stop every XSS attempt, but it helps limit what gets through in the first place, especially if you use allowless instead of trying to block known bad input. Combine that with proper escaping, and you're already covering most of the common attack paths. For even more protection, you can implement a content security policy, or CSP. It tells the browser which scripts are allowed to run and blocks everything else by default. That way, Even if a malicious script somehow makes it into your page, the browser can stop it before it does any damage. None of these defenses are perfect on their own, but together they create a solid barrier against most XSS attacks. So let's recap. Cross-site scripting happens when a website accidentally lets attackers inject scripts that run in other people's browsers. We looked at stored, reflected, and DOM-based XSS, and how they all come down to one thing: code execution through untrusted input. The best way to stay safe? Escape what you output, validate what you input, and add extra layers like content security policy wherever possible. XSS is one of the most common web vulnerabilities out there, but with the right habits, it's one of the most preventable too.